So far, we have covered the first order differential equations and solving them through separation of variables method and the linear method. So next what we have to look at is where is the first order differential equation actually used? So one of the examples that I've given here is known as a tank draining problem. It's a pretty famous one. But there are also other examples when you can use it like for population growth in economics. And as I mentioned in heat transfer, you can use it for both heat conduction and also Newton's law of cooling, the convection method. So there are actually like a lot of applications for first order differential equations. But over here, we are primarily going to keep our focus on solving the differential equation for real life situations. So this is one of the very famous one, um, and we'll be covering this in this video on the next one. This is it's a pretty tough problem because we are having two tanks over here. So we're going to have tank 1 there and tank 2 over here. So as you can see, there's an inlet over here which gives salt water, and it flows in tank 1 at 30 liters per minute with a concentration of 20 grams per liter. So what does 20 gram per liter mean? So it means that for every 1 liter of water, there's going to be 20 grams of salt in it. So it enters tank 1, which has a capacity of 1000 liters. So initially, this 1000 liters of water in it, there's no salt in it because I can know from the concentration which says that 0 grams per liter. So this is just pure water in tank 1 at time equals to 0 actually. Because when this salt water is going to pour in, the concentration is going to change. Do you think the volume is going to change? Yes, because if you can see the next, the draining tap, you can see that it goes out at 40 liters per minute. So if you think about it, the water comes in at 30 liters per minute, the salt water, but it exits at 40 liters per minute. It means that after a certain period of time, the tank 1 is going to become empty. You can easily calculate the time taken for this to drain because you have the number of liters and the rate at which it comes in and the rate at which it goes out. We'll be doing that as a part of this problem. Once we figure out what happens in tank 1, we then start to analyze what happens in tank 2. So tank 2 is also 1000 liters capacity. But initially at time 0, it's going to have 50 liters, 50 gram per liter of salt concentration in it. So for every 1 liter of water, there's going to be 50 grams of salt in it. And another thing about this tank, is that it's a steady state. What does it mean? It means that salt water entering the tank and the salt water exiting the tank is at the same rate. So if you look at the volumetric rate, they're both the same. So you can just, if you think about it, you can just think about it in this way. In 1 minute, 40 liters of salt water is going to enter, and at the same minute, 40 liters is going to exit. So tank 2, is always going to remain at 1000 liters. But the concentration is definitely going to change because this one is going to come in, and that is only 20 gram per liter. So we expect the concentration of this to reduce from 50 gram per liter. So now we need to look at what the question asks us to find, and we need to go about figuring that out. So usually the question that's normally asked over here is, what is the concentration or what is the amount of salt after a certain period of time, let's say t, in tank 1 and tank 2. So for this, we are definitely going to use differential equations to solve it because when you look at this problem, you're going to have grams per liter and you're going to have liter per minute. So you can somehow get grams per minute. So that is the rate of change of the amount of salt as time passes. So we're going to have a differential equation with the rate of change of amount of salt in it, and we'll eventually figure out what the value for the amount of salt in tank 1 and tank 2 for in a general case for time t, and also for a particular solution at time t is equal to, let's say, 20 seconds or 30 seconds, whatever the question asks us. So we'll look at the solving part in the next video.